do one more example. Move on to our next problem here. As we look at our next piecewise defined function, we got another one similar. We got a quadratic piece to it, and we've got a linear piece. So I want to do the same thing. I want to build a table of points and sketch it so we can analyze it. So let's go ahead and do that. And I'm going to go ahead and talk about the first piece. So f of x equal to negative x plus 3 squared. And here's the important part, right? Remember, right, we're looking at all the x values that are greater than -5 and less than or equal to -1. So those are our restrictions. Those are important. We need to make sure we include those, right, when we build our table of ordered pairs. So let's go ahead and do that. So we got our x and y. Let's build a table, get some quick points to go plot. So I'm going to start with -5, right? It has to be greater than -5. And you won't put a little open circle there. As we know, -5 will not be part of the graph because, again, it's greater than, not greater than or equal to. What's the y coordinates? Let's go evaluate our function. So f of -5 equal to -5, right, plus 3 squared, which is equal to negative of -2 squared, right? As we simplify down, and of course, -2 squared is 4, so I end up with -4. So my point on the graph of f of x, this piece, this quadratic piece, will be -5, -4. So at -5, -4, let's go ahead and begin to look at this graph. Right here is -5, -4. You see I'm putting in that open circle, right? Not part of the graph. That's important. All right, let's go ahead and do some other points. Let's do -4. What's f of -4 going to give us? Now again, -4 is something we can use. It's greater than -5, is less than or equal to -1. As we simplify, we got -4 plus 3 squared. So we take the negative of that. Well, -4 plus 3 is -1. -1 squared is 1. So we end up with -1. So we get the point -4, -1 to go plot. So we're going to pass through the point -4, -1 right here. So I'll go ahead and label that ordered pair. And then we could find some more. Let's go ahead and do -3. F of negatives to the integer values. Get a detailed graph against a curved piece. Right, it's part of a quadratic. All right, and this one's going to be a little upside down U shape going on with it, because we have a negative x squared term. But as we simplify here with -3 plugged in, right, what do we get? I get the negative well, -3 plus 3 is 0. So we get -0, which is 0. There's no negative value of 0. So we have -3, 0. So we found a x-intercept point, which is always important. And we'll go ahead and plot that point. And as far as integers goes, there's only 2 more to find. So maybe we'll go ahead and finish off the integers. How about f of -2? Well, that would be the negative of -2 plus 3 squared, right, which is the negative of 1 squared. And -1 squared is -1. So -2, -1 is a point this graph, or this piece goes through. So I'll go ahead and label that point, -2, -1. And then our last value, we got to always use the restrictions. Remember, it has to be less than or equal to. And I'm going to put a little closed circle beside this. So let's go find f of -1, which is equal to negative of -1 plus 3 squared. So I got the negative of 2 squared, which is -4. So I have the ordered pair of -1, -4. So -1, -4, I'm going to put in a closed circle, and that's the end. Let's go ahead and connect these. So what does this piece look like? So there's a sketch, that quadratic piece. All right, so now let's go build the second piece here. So now we're looking at our second piece from our function. So we got f of x equal to 2x minus 2 for all x values greater than -1. So as we build our table of ordered pairs, our x and y points, Now greater than, a little open circle here. All right, we're not going to include this point, all right, from this piece. Now with that said, what is the y value? What's the y coordinate? So what's f of negative 1? That'd be 2 times negative 1 minus 2, which is negative 2 minus 2, which is negative 4. So we get that point again of negative 1, negative 4 we found in our last piece. So open circle, well, we already have that point included from the other one. So we do include negative 1, negative 4, but it's not defined from that linear piece. It's defined from the quadratic piece. Now we need a few more points, at least a couple. This is a line. It won't take long to find out what the graph's going to look like. 2 points will give us an accurate picture of the slope of the line. But with that said, let's do another one. Let's let x be 0, right? That's the integer value greater than negative 1. And that's going to let us find the y-intercept point. And we let x be 0. So I've got 2 times 0, right, minus 2, which is 0 minus 2, or negative 2. So our y-intercept point in the second piece is right here at 0, negative 2. So this line passes through 0, negative 2. All right, let's look at 1. Do another one. What's f of 1 give us? That would be 2 times 1 minus 2, which is 2 minus 2, or 0. So now we're finding the x-intercept point. 1, 0, this line passes through. And that's enough. I do have all my intercepts. I'm going to go ahead and graph in that second piece. But there it is. There's our piecewise defined function. Not hard, right? We're just finding some easy points to plot based off the restrictions. State the domain. Just analyze it. So domain, let's find all the x values that make up the graph of this function in front of us. Where does this graph cover the x-axis? Well, our minimum x value, how far to the left does this graph go? We're going left and right for domain, right? On the x-axis. It begins at the point negative 5, negative 4, except that's an open circle. So as I write my domain, I need a parentheses on the negative 5. All x values, what, greater than negative 5. From negative 5 on to infinity, you'll see your graph. No matter where you look to write negative 5, you'll find your graph of this function from one of those two pieces. So all real numbers greater than negative 5. So we don't see anything to the left of negative 5, and we don't include negative 5. Don't put a bracket, right? Bracket means we want it. Negative 5 is undefined based off the restrictions from our first piece having to be greater than negative 5. Our range, where's the graph cover the y-axis? Let's list all those y values. Well, how far down does the graph go? Well, you can see our graph right here at negative 4. Negative 4 is the minimum y value. Now, negative 4 is included, even though negative 5 and negative 4 is not part of the graph. Right? We have our point over here at negative 1, negative 4. So we need a bracket on negative 4 all the way to infinity. So negative 4, all y values greater than or equal to negative 4. Find the y-intercept. The y-intercept point we've already got labeled from that second piece, 0, negative 2. Our y-intercept. And our x-intercept, we have 2 of them. We have one at negative 3 on the x-axis, so negative 3, 0. And we have one at x equal to 1. It's another 0, so 1, 0. Is this graph continuous? Yeah, if you take this graph on the domain, right? If you look x greater than negative 5, you never have to pick your pencil up. This one is continuous. No breaks to write a negative 5 where our domain take place. So that's piecewise defined functions. So that's the first thing we did there at the beginning of Module 4. So it's a good review of piecewise defined functions. Back from Module 4, it's the lecture. So we'll take a break and continue on.